Petrol and diesel are fossil fuels which are produced from crude oil, and crude oil is a limited resource. At the same time, the automobile is a popular means of transportation, and large emerging markets like South America, China and India will increase the demand for new cars in the foreseeable future. The burning of fossil fuels in automobile motors not only promotes the global greenhouse effect. The increasing number of vehicles being registered stands in contrast to decreasing sources of energy. How can this problem be met?
We will have to cooperate increasingly, and this is an important theme, I believe. Both industry, like Audi and Shell, as well as with government, academia. We are really challenged, almost as a species, to find solutions.
This means that energy sources will have to be found that are sustainable and clean. To this end, Audi is working on a combined strategy in which engine development and alternative energy sources go hand in hand with the optimized driving habits of the motorist, in order to reduce the amount of CO2 being emitted.
We want to reduce our CO2 emission till 2012 for about 20%.
4 alternatives are emerging: electric power systems, biomass, alternative fuels and hydrogen. Automobiles with electric power systems are common enough, but they have one noticeable disadvantage: limited range.
If you put in perspective what the energy density, for instance, is of a battery compared to gasoline, that big battery block has the same energy content as that very little small bottle of gasoline.
On top of this, automobile batteries are being fed with energy that has been acquired by conventional means, meaning for the most part from nuclear power or coal-burning power plants. Another alternative is the hybrid drive, combining a combustion engine with an electric powertrain. The battery of the electric drive is only activated in specific driving situations, and is furthermore recharged during vehicle use via braking energy, for example, which leads to the unrivaled mileage resulting from hybrid technology. The potential of the electric drive is evident. The fact that the electric drive is free of pollutants is in its favor. Its limited range and the fact that the energy source for automobile batteries is usually conventional speak against it. The electric and the hybrid drive are both promising technological advances, as long as the storage capacity of the batteries is increased and the electric power can be gained from renewable sources. Another approach is pursuing the principle of sourcing fuel from biomass. Petrol can be replaced by ethyl alcohol, which is obtained from sugar-containing plants such as sugarcane. And for self-ignition drives, diesel is produced from palm oil, sunflower seed or rapeseed, for example. Burning these alternative fuels does produce emissions, since plants bind CO2 during their life cycle. Because they release this CO2 when dying, biomass fuels have an almost neutral CO2 balance.
The amount of carbon released in the use of the fuel is exactly the amount of carbon which is taken up by the living plant. And this is what we call the carbon cycle.
Nonetheless, these fuels have a serious disadvantage. They are practically produced from foodstuffs, which leads to an explosion of food costs on the world market, among other things. In conclusion, we can say that biomass of the first generation has a negligible CO2 balance, as well as the possibility of practically unlimited supplies, giving it clear advantages. But the negative effect on the price of food stands in contrast. The second generation of biomass fuels to be introduced will therefore be obtained exclusively from plant waste and no longer from edible crops.
We don't feel that you should get into competition with food, especially since we have is the second generation biomass fuels, an alternative which do not have these drawbacks. Here we are using biomass waste.
Second-generation biomass fuels show a more positive balance. Besides the good CO2 balance and its practically unlimited capacity for replenishment, the fuel will above all not be competing with food supply. A further diesel fuel substitute can be obtained from gas. In a special chemical process, gas is liquefied, which is where the term gas to liquid, or GTL, comes from.
Well, gas to liquids became relevant to Shell somewhere in the 70s. It behaves like diesel, you can call it that way. So you can use it in a diesel engine and it will reduce emissions as a consequence.
During a GTL operation, the nitrous oxide emission can be reduced by 50% and the CO2 emission by 10%. The disadvantage? Gas is a finite resource. To conclude the subject of gas to liquid, it can be said that it can be used in conventional motors and has lower emission rates. Speaking against this technology is the fact that gas is simply a limited resource. Alternatively, gas can be used directly as a fuel. In order to do this, however, it first must be compressed, hence the name compressed natural gas, or CNG in short. An improved ecological balance, as offered by the Audi A5 CNG test vehicle seen here, is juxtaposed by technical problems, however.
Gas needs a lot of volume if it is not compressed, so we have to compress the gas in order to have a certain energy density. But even so, you need 5 times more space, and that's the big problem of gas cars.
Finally, the problem of extensive supply must be met. Thousands of petrol stations would have to be expensively fitted with the special pumps. So CNG has the advantage of lower emissions, as well as the fact that there are larger gas reserves than there are oil reserves. The disadvantages? Gas has a significantly lower energy density than petrol, the service infrastructure is not in place, and gas is simply a limited resource. Industry and research have placed high hopes in hydrogen technology for a long time now. The compelling argument? Hydrogen is 100% pollutant-free. The problem? The fuel is obtained from water through electrolysis, a procedure requiring energy. The hydrogen produced only contains as much energy as was used during the electrolysis. Strictly speaking, therefore, hydrogen is an excellent medium for the storage of energy. Audi has been researching fuel cells for some time now.
The future is hydrogen, and Audi in 2004 introduced Audi H2, the fuel cell concept car. This was a kind of first in the industry.
In conclusion, we can say that hydrogen is free of pollutants. To its disadvantage, however, are the lack of service infrastructure and the fact that the original source of energy is conventional. Hydrogen has the potential to become a clean fuel for the future, as long as a clean original source of energy can be produced. A large palette of possibilities is available. The biomass industry is already producing alternative fuels today that are not competing with food supply, while GTL and CNG present the possibility of falling back on an environmentally friendly gas. In the future, hydrogen could take the place of petrol and diesel. And perhaps imaginative inventors and engineers will conceive a fuel that at present we could not imagine in our wildest dreams.